Hi guys, I'm so glad that you are in our Math 7 honors classes at Eastmont Middle School. You're going to be so excited because guess what? We start our base 10 unit today. So today we're going to review place value specifically with base 10. So this is part of the honors curriculum. So excited you're here and ready to go. Alright, so let's go over our lesson objective. It states, I understand how place value works in base 10. In fact, you have been learning base 10 ever since you were basically in kindergarten, maybe even sooner. Earlier than that, I mean. So think back to when you were learning to count. Maybe you used your hands as a helper, but you were using, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then eventually you got to 10. So you had all fingers up in the air. So this is how we got to a base 10 system. We have 10 fingers and 10 toes, and that's kind of how we came up using base 10 as a way to organize things. So we organize them in bundles of 10. And today we're really getting the foundation of the bases that we're going to explore in a couple of weeks. So in a couple of weeks we're going to learn about base 2 and base 5, but really we can't understand these bases until we really understand base 10. So let's go look at that diagram. Here is our diagram. You're like, I've seen this before. This is nothing new. So why are we learning this one more time? Well, let's kind of dig down deeper. It says, our number system is based on the number 10. How far can we count until we need to use two place values? Excellent question. Let's dive right in. So first of all, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we're like, what do we do after 9? This right here is our bundle. This is our bundle of 10. So, how far can we count until we need to use two place values? The answer is 10. Ding, ding, ding. We're learning base 10 today. So, let's look at another one. How far can we count until we need three place values? Well, all the work that we did to answer that second question is going to come in handy. We just said in order to start the second place value, or two place values, we need to start again with our 10. So that 9 refreshes and goes to a 0, and we start a new place value with our 1. Well, that's exactly what happens when we move to the hundreds place. Here we have our 98, our 99, and we can't move on because there's nothing bigger than that 9, so it refreshes. It starts at 0 again. Wait a second, what am I supposed to do with this 9? The exact same thing. It refreshes again to 0, and we're going to place it, that 1, right in front. So this is initiating the three place values. So how far can we count until we need three place values? What? 100. Ding, 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 ding. I'm zooming in. 100. So let's look at our big overarching question. So if you have nothing that you learned from this video, I want you to get this answer. How many times larger is each place value than the previous one? Think time. How many times larger? What base value are we learning today? If you said times 10, you were exactly right. So each one, we're moving up by 10. We're moving up by 10. Times by 10, times by 10, times by 10, times by 10. That makes sense because today we are learning base 10. Base 10. All right, let's go ahead and look at our next section. All right, I had this question on the last slide. It says, why are 2, 20, and 200 different? I want you to think about what we just learned on the last slide. What do you think the answer might be? All right, let's see what I wrote down. And by far, this is not the only answer. I know you guys have brilliant thoughts. It states, 0 gives number size by indicating place value. What I mean by that is each time we go up 1, we are multiplying by 10, and we are adding an extra 0. So multiplying by 10 indicates our place value. And we do that with zeros. So let's look at our base 10 table that we've seen before. Here it states, use a base 10 table to show the difference between 2, 20 and 200. So let's stop there. First of all, I want you to think, what place value is that 2 in? It's in the ones place. Yep, so that we're going to put that 2 in the ones place. What place value is this 2 in? It's in the tens place. Good. So then that 0 means we have 0 ones. We have no ones represented in the ones place. And then that 2 is in the what place value? Yeah, the hundreds place. So then we notice that there's no tens and there's no ones represented. So that's kind of how we use our base 10 table. If you want to, I'm going to give you a challenge. It says, then write 6 other 3-digit numbers in a chart to compare place values. Feel free to take on that challenge. Before we end our video, I just wanted to give a reminder about numbers that are bigger than 0 and numbers that are smaller than 0. Notice that we use the suffix ds to represent numbers that are greater. So for example, thousandths, hundredths, but when we get to numbers that are smaller than 0, which are over here, we use the suffix ths. So for example, like hundredths, thousandths. It's kind of like I'm making a weird sound at the end, and that's exactly what I'm doing. So make sure when we're talking in class and we're using that academic language, especially in honors, you are focusing on the sound. All right, so on Friday in class, we are going to go over this worksheet on base 10. You will be asked to determine the place value for the following problems, as well as determine the place value for the underlined digit. So I hope you are super excited about place value and different bases. Congratulations on taking honors. Again, super excited to have you, and I'll see you in class tomorrow. Have a good one.